Similarly, if we have another problem very similar like this. Suppose there's a square and wind is blowing along one side of the square. Suppose this side of the square, wind is blowing like this all over the square. Wind is blowing like this. The wind velocity is u and the aeroplane velocity is v. Now we have, and the side of the square is a. Now you find the time taken for an aeroplane to go all around the square in a straight line. So it will start from A and go straight to B, start from B, or in the continuous motion from B it will go straight to C, and from C straight to D, and from D straight to A, come back to A. So on a roundover journey from A and then back to A, what will be the time taken for an aeroplane? And it has to move in a straight line, AB, BC, CD, DA. So it's another chance for you, if you didn't get the previous one right, to get this one right. And you should get this one right. See, you don't have to solve too many problems. Solve few problems and spend some quality time with them, thinking about them from various angles, various perspectives, and then you'll be able to solve any new problem. Actually, what you have to do is you have to keep yourself moving, push yourself. So try hard to get answer for this one and try hard to get the right answer for this one. Okay, let's start discussion. Let's start from B. Let's start from B, or let's start from A. No problem. Starting from A is pretty simple. It's just the same as the case we did before. You have to go from A to B, and the wind is blowing in this direction. Okay, so you have to. The aeroplane should keep an angle, try and maintain an angle, theta, like this, such that V sine theta is equal to u, so that it cancels the velocity of the wind. So it cancels the drift effect caused from the wind. So it doesn't go downward. V sine theta cancels the velocity of wind, cancels A, and it go ahead with a velocity of V cos theta. So time t1 from A to B would be A upon V cos theta. Theta is not a variable given in the problem. You have to eliminate theta using sine theta is equal to u by v. If sine theta is u by v, then cos theta is equal to root over 1 minus sine square theta, 1 minus u square upon v square. So from here, if you put cos theta here, theta would be eliminated. So this is t1, then t2, t2 from B to C. You're going against the wind, and they are anti-parallel to each other. So V will be in this direction, U is in just opposite direction, so the net speed would be V minus U. So that would be A upon V minus U. And T3 would be, again, it will be exactly the same as from A to B. If you go from C to D, you draw a diagram like this. Wind is blowing in this direction, you have to go in this direction, keeping an angle theta such that V sine theta cancels the effect of the wind, and it goes with a speed of V cos theta. So T3 is going to be the same as T1, and T4 is going to be the same as no, for T4 the wind is supportive to the motion, so the time taken would be A upon V plus U. You add all these three, can substitute cos theta with this. It will be a very little bit of manipulation and you will get the answer. The answer would be 2A upon V square minus U square into V plus root over V square minus U square. You should get this. You got it? Good, very good. You're working hard. You're gonna get the fruit of this, dear. Okay, in the previous problem, suppose the wind was not blowing along one side, the wind was blowing along the diagonal. This is the diagonal, and suppose the wind is blowing along the diagonal. Okay, and all the parameters remain the same, and the job of the aeroplane also remains the same. The aeroplane has to go round and round the square. So what will be the time taken now for the aeroplane to go round and round the square? One time. So Another problem for practice, if you have another opportunity, if you didn't get the answer the first two one, you better get the answer for this one. And I'll not be solving this because the line of thinking and solution will be the same as the previous two cases. I'm giving you the answer. So you please do the practice and see if you are getting this. This should be the answer.